Hi, welcome to the next video. Today we are going to do MANOVA. We use MANOVA when there are more than two dependent variables and more than one independent variable. So we are going to do that today. In such a case, we cannot use ANOVA. So we have a data of 872 participants here, and our independent variables are these two, gender and work location. We are going to check that if these two IVs, gender and work location, impact the employee satisfaction depending on their gender and their work location. Our dependent variable are these five. So these are employee satisfaction levels in different five areas. If we do ANOVA, we'll have to do ANOVA for each of these five. We don't want to do that. So we'll be using MANOVA to streamline and do it at once. So we'll go to Analyze, General Linear Model, Multivariate. We'll add our DVs here. Fixed factor will be our independent variables. We'll go to Options, check Descriptives, Effect Size, and Homogeneity Test to check the assumption of MANOVA if it is fulfilled or not. Then we go to Plots and we'll create a plot to check if there is an interaction factor or interaction impact of these two independent variables or not. Okay, so this gives us the interaction factor. Remember, we'll do the post hoc analysis only if we found there is a significant mean difference between the groups. If not, then we'll not do post hoc. So we're gonna do okay and go to the analysis. Okay, now this is our overall scenario. We have different sample sizes for each independent variable size combinations, and that can impact our results. That's one thing. You will see in descriptive statistics also that there are different n, and that can impact our overall results as well. Now, if the groups are different, we cannot compare them, but homogeneity of variance tells us that if the variances of different groups are same, then we can compare them, their means, and we can find the mean difference. So we're going to also check the homogeneity assumption. But as you can see, for every dependent variable, there are different ends. Okay, next we go to Box's test of equality of covariance. As you can check the significance level here, that the equality of covariance is not violated. This assumption is fulfilled. In MANOVA, Box's test checks what Levin's test checks in ANOVA. It checks the assumption that the null hypothesis that observed covariance matrices of dependent variables are equal across groups. That means that the variance matrices across different dependent variable groups is same. There is no significant difference. As P here is greater than 0.05 significance level, we sustain the null hypothesis and we say that there is no significant difference because it is not meeting the significance level. Once our variance assumption is met, we go to multivariate test of all the variables. We'll check the significant test values for gender and work location factors and their interaction factor. As you can see that all the significant values for gender is zero point 0.3, which is significantly higher than our significance levels of 0.05 and 0.01. So we'll reject this, that there is no significant difference. Null hypothesis retains. Similarly, for work location, the significance level P is significantly higher than significance levels, and similarly for the interaction factor also. So we are not getting any significant values here. So we'll reject that there is any kind of significant mean difference between the groups. If we look at the effect sizes for all these three, it is 0.005 to 0.007, which is very, very low, which again strengthens our conclusion that there is no significant difference between groups. Now, if we go and check the sample for each group, we have five dependent variables here. And if we check the homogeneity of variance, the sample assumption for each dependent variable, we can see that significance values are way higher than 0.01 and 0.05. So our null hypothesis remains also in this case as it retained in Box's test. As for our sample assumption, this means that though our n is different for each group, the variances of different groups is almost same and it fulfills the assumption of ANOVA and MANOVA. Now I'll check the significant differences between subject effects for each dependent variable separately. And if we go to gender and we have 5 dependent variables here, and if we look at their significance values, you can see that for all the 5 dependent variables, it's way higher than our significance levels of 0.05 and 0.01. So there is no significant difference. Similarly, these significant values are also not considerable, way higher than our cutoffs. So our null hypothesis will retain, and we can say that neither gender, work location, or their interaction, gender into work location, has any significant impact on the satisfaction levels of different groups. You will see that the effect sizes for these differences is also very small, which again strengthens our conclusion. Now we come to the plots, and here we have gender and work location. And these lines, because they are mostly overlapping and almost parallel, it shows that the group means, the marginal mean group means are almost identical and there is no significant difference. And if we go to the next graph also, we see that here also lines are almost overlapping or there is no significant difference or gap. So the final conclusion that we come on the basis of this data set is that assumptions are completely fine. There is no significant group differences, so there are no significant effects. And effect size also tells us that. This is confirmed by our test of homogeneity of variance, significance levels of p-values, eta squared effect size values, and our plots of marginal means. Thank you for watching the video. I hope it was helpful. If you have any questions, please add in the comments. See you in the next video with more research topics in data analysis.